So first of all, thank you for the community, for Linux Foundation to get me to be able to have an opportunity here to speak with you guys. So my name is Tom Yin. This presentation here is about how to make multi-cloud networking easier, right? So simplifying multi-cloud networking via a virtual gateway, single virtual gateway. And this presentation was put together by quite a few contributors. We're a small group of folks that are spread around the world. And we had the special help of Oleg from Equinix also to make this presentation actually work. So I want to thank everybody that's on that list of contributors. And we'll just get going here. And I know Sunny wants me to try and keep it within schedule here, or bring it back to schedule. So I'll try and accelerate this. So really, I think what I want to talk about is what is the future of IT architecture? I think there's a lot of, we're living in exciting times right now where regulatory costs and I think privacy, security, and transparency is actually happening all at the same time, right? Never have we been in a situation where, previously it was all CPU-based, x86. Now with the world of floating point GPU processing capability, that this has now forced us to actually tap into floating point calculations so that we can actually take advantage of superpower computing, right? So we've seen it before from Gen AI through to now drug research, through to potentially electrification in terms of self-driving. This is all happening all at the same time. So what we don't really know is that how will the IT architecture actually evolve? I think that, to me, is probably the most important thing. So what I want to try and highlight here is what are some of the key feature sets that I think we should be aware of, right? So data, as we all know, is probably the most important thing, right? So you want to protect your data at the end of the day. You want to be able to get access to those supercomputing power that are available in the hyperscalers, right? Or specialized GPU providers, right? So you want to be able to gain access to those things. You want to have privacy and security, right? And then you want to manage your costs. At the end of the day, there's no good having a business if you can't actually manage your costs. I've worked previously for a telco, a cloud provider, and a data center provider. That's my background, right? And I've seen and I've worked with a lot of enterprises to know that some of the cloud providers, SaaS providers, have actually gone so successful. Unfortunately, they haven't been able to manage their costs. They've actually exceeded their spend. So cost is going to be an important factor here, and even more so, I think, in the new computing world. And then finally, I think you want to be able to tap into those new business opportunities, right? So what we have essentially done is look at all these different criteria and build a demo that hopefully maintains and enhances upon those capabilities, right? So the first one, I just wanted to step through it here, is we're using, obviously, an x86-based bare metal, right? So we want to be able to make full use of open source capabilities, right? We tried it out in terms of, at the end of the day, in terms of IT, the internet is still based on BGP. That's not going to change, right? P4 programming, I think, potentially has the opportunity to actually change that, but I don't think that will actually supersede BGP. So that will still be maintained. So what we're doing here is building and proving out using BGP and SONIC and VPP capability that we can actually scale this for the enterprise to actually fully use. So we tried it using VPP over VLAN. We want to try and using NAT, and then eventually we want to try and using VXLAN over VTEP. We didn't do those two, but we did use BGP as well as the VLAN capability. In terms of open source technology, the demo is built obviously using SONIC, using the VPP capability, Postgres, SQL, Apache, Prometheus, and Grafana to actually maintain and monitor in terms of the capabilities and proof points. And then at the end of the day here, we want to be able to actually tap into those CPUs and GPUs, right? So that's really the environment, all right? So that's what we want to try and prove. And we did that, actually, this group of team, we did it within 2 weeks. This is how good it is. None of us was really, I think, SONIC experts, so to speak. I think we grabbed it from the GitHub, from the actual true open source. And what I want to try and go through here is to actually highlight what are some of the challenges, and then leave at the end of this presentation with a repo to which you can actually download and actually gain access to in terms of what are the proper links that you can actually get to download it. So what we did prove out is the fact that SONIC and VPP SDN data plane acceleration on x86 bare metal servers actually do scale, right? They do scale, and they do meet the performance with minimal, almost line rate, right? Because it's on layer 3, it's almost line rate capabilities. So that's what we actually did prove out. So this is the topology. So let me just run through very quickly here in terms of what we actually built. So each of these are actually run on its own containers, right? And we have AWS and Azure on each of the cloud providers that we're able to connect with. And we were able to construct all of this within 2 weeks. 1 week was to actually set up the actual environment. So it's a day 0 preparation, right? Making sure that we have the actual access to the accounts, setting all the accounts up, both on the Equinix side as well as on the cloud provider side. All right, and then download all the GitHub open source capabilities. And then the second week was to actually try and compile it and make sure that it runs. And we found that there was quite a few broken links, for example, and be able to make sure that we get the right code and be able to actually compile it and execute. And then set up the actual appropriate stitching that is needed to actually make sure that it actually does work. So this is the quick environment here. I won't go through it in details in conscious of times, but happy to try and talk to you guys offline afterwards. But just to highlight, so there's Azure on one side, as I mentioned. We got AWS. We have Grafana and Prometheus sitting on one of the servers there. So there's 2 bare metal servers side by side there that we actually set up. These are small instances. We just wanted to make sure that it does work. So we proved it out. So this is using the Equinix Cloud Fabric to actually connect to those. And for those of you, why we actually chose that was because we were conscious of the fact that ingress costs of cloud do add up quite a fair bit. For private connectivity, it's significantly lower. So that's the primary reason for using the cloud fabric. Those are probably the main points that I just want to try and quickly highlight. The observation in terms of the roadmap. So as mentioned there, there's additional enhancements that we want to try and make eventually in the future, because this is single virtual gateways. We're not able to actually manage this across multiple gateways. So there is a MEMIF module that we potentially need to propose back to the community to be able to actually make that work so that we can actually manage it across a platform, across multiple virtual gateways. So that's something that we are working, hopefully with the community's approval, to actually get that added, is to actually enhance upon that. So that's one other thing. Exposing of the VPP NAT and VXLAN, I think it was talked about earlier today. VXLAN is not available yet. So we want to be able to actually enhance and accelerate that capability as well, and gain support directly through it. I have a video that I actually want to try and run here. Not sure why. So anyway, so I'm gonna pause there. I think in the conscious of time, I'm probably gonna be running over. So why don't I open up, I guess, Sunny, for any questions? Yeah.
Any questions?
It seems like between your connections and my computer is not. Yeah, I already did that.
All right, Patrice from Cisco. I think it's more like a general comments for the community here is that I've seen a lot of new presentation today where people are requesting more and more and more and more features. So I think we all deserve to question ourselves, do we need all of these features? So just make sure we're not starting to pollute the SONIC, because it's really nice right now because it is pretty light, and if we make it so heavy, we will hate it at some point. So thank you.